Recording. Okay. Hi everyone. This is Let's Discuss Papers and After Reading It. In this journal club, we picked up and started reading paper 2 hours ago, and then from now on we are gonna discuss the paper. Today we have me and Chanshen. Chanshen, can you introduce yourself?
Yes. Hello, everyone. My name is Qian Chen, and I'm currently a PhD student at the Chia Lab at Monash University, Australia.
Thank you, Chanshen. Me, Yota Kawashima. I'm doing research engineering QSD Chiba, Japan. Today, we are going to discuss a paper titled Keep It Real, Rethinking the Primacy of Experimental Control in Cognitive Neuroscience, Natase et al., 2020 from NeuroImage. Before starting discussion, I will first give a quick summary of this paper. So in neuroscience, of course, we want to understand how the brain works in the real world environment. But the real world is too complex, and the brain itself is too complex to understand or to interpret by humans. So when we investigate the brain, we focus on a small number of variables in that experiment by setting up some artificial task, fixing the many, unrelated variables in an experiment. And then based on these experiments, we try to find some underlying principle in the brain and then hope to generalize that principle to the real world environment, how the brain works, how we behave in the real world the real world environments. However, the problem is that it does not seem to work well. I mean, the principle or the rule we found in the artificially or strictly controlled experiment cannot be generalizable to the real world environment. So we need to change the way how we think, or we need to change the way how we investigate the brain. That's what this paper basically is suggesting. And this is opinion paper, so they did not provide or did any experiments and did not provide any result for in this paper, but they are suggesting that one possible way is to sample or use the stimuli conditions based on or just select the stimuli or conditions based on the distribution from the natural environment. So what I mean by this is that when we design tasks, we focus on a variable or that we want to investigate, that we are interested in. It's kind of a handpicking. So this suggests that instead of doing that, we should think about first how the real environment is like, and then based on that we need to make, or based on that we can make a hypothesis and then test that in a real world or more ecological task or in the more ecological experiments. That is, I think, what this paper claim. And of course, they said that it's really important. I mean, the classical, well-controlled experiment is important. That's undeniable. But if we want to, find more ecological generalizable result, we also need to think about how we, make a hypothesis. That's what this paper said, and this is my summary. Chanshin, do you want to add anything?
Yes, I largely agree with your summary. But I just want to add one more thing that I personally think, is I find pretty important because I'm doing things, which is that when you are investigating a certain, let's say, psychological phenomenon, you don't want to isolate that variable out and not consider the interactions other variables would have on it. What I mean is that, for example, they bring up an example of face perception. So a traditional controlled experiment would be to generate these face stimuli that are kind of just like this, no hair, no, whatever. They try to strip down as many irrelevant variables such as like race, maybe like skin color, because they tend to use black and white instead of colored stimuli, and also like no hair, no hairstyle, no facial expression, and static stimuli, and then they are presented in a random sequence. But that does not really mimic how we see faces in our everyday life, because in everyday life we see people walking around and then we see the face from different angles and they have different expressions. Our brain just naturally factor these dynamic and semantic contents together to perceive the face. So when you say you want to investigate face perception, you want to investigate that rather than, how the brain reacts to a random sequence of face without hair. And if you generate a model from this kind of control experiment, then it's hard to say how much it explains everyday perception of faces.
Okay.
So it's like a interaction.
Yeah. Okay, thank you, Chen. Yes, it's a kind of example how classical, controlled experiments are weird and does not fit well to real world, how the relation, between human brain and environment behaviors. Okay. And do you want to add anything?
Yes. So I have two things to talk about. So the first one is reading this paper reminds me of a lot of these so-called debates and contradicting findings in both cognitive neuroscience and also like just cognitive psychology back when I was doing undergrad. You know how at least for me, when I was doing cognitive psychology class in undergrad, when they introduced the history of, let's say, visual search or like working memory, the narrative tends to be like, at the beginning, there's someone who find, people tend to rely on this mechanism when they do visual search. And later, there's an opposing opinion where they propose, no, it's the other mechanism. And then they end up with the dual processing theory where actually both mechanisms matter. And in cognitive neuroscience, there's also, something like prediction and prediction error. Do we see what we predict or do we see the error of our prediction? And it just so happens that both sides would have a lot of supporting evidence and it makes things very confusing. But the point is that with this kind of, the paper we read today, the message is probably that the brain does both. It kind of utilizes these different mechanisms in different contexts, right? It doesn't just like, I use one mechanism for everything, even if it crashes and it's not optimal in some of the situations. Basically, the brain is smarter.
I see. Yeah, I see. I agree with you. And I don't think that, brain has a single, rule, working principle.
Yeah.
So you should think about, or consider many or possibilities. But at the same time, I think what the author says is that, brain may not work as we, can interpret, or
Yeah.
sometimes, it just work how it is and we just can't interpret it, like, deep learning. In this paper, they mentions that how, deep learning works. They just, input many, naturalistic image, for example, in convolutional neural network, and then it, performed quite well. And there, they just, give some, rules, but, when we train the model and then test it, and then what we can get is only the performance. And it's not easy to interpret what's happening in the model, the deep learning models. So, but this is very, difficult in a sense, because, I want to, understand what's happening in the brain. So interpret the brain. The principle I want to, find the, in a sense, the rule, the principles. But this paper suggests that, it's not always.
There's no rule.
Yeah, in a sense, yeah. So I agree with what they say, but my personal opinion is that, yeah, but still I want to find something.
Yeah, I was also talking to Ariel the other day about maybe the brain just doesn't work in the way that we can currently understand with like theory, like our current theories. Just like you are trying to apply classical, Newton's rule on like, how like the universe,
Yeah.
like how the I'm stepping into. Anyways, so if Newton's rule doesn't apply to events of physics that's in like the universe that's like not in here, right? You need new theories or new science to be able to explain how the brain works. That's possible.
You made a kind of interesting link between neuroscience and physics, and then that kind of reminded me that maybe quantum cognition.
Yes.
So I still, don't really understand the quantum cognitions, but the idea is, I guess, or kind of, linked to this paper, I feel. Because in a classical, cognitive science, just, we have intuitions that's just, natural for us, more easy for us to understand.
That reminds me, the entire cognitive science thing kind of started to appear after computer becomes a widespread thing, and people started to think maybe the brain works in part similar to how a computer would work, and that's why they investigated the cognitive theories of psychological phenomenon, and also like the underlying neuromechanism of those phenomena in this kind of mechanical and controlled way because of the computer. But the brain doesn't work like a computer. Right?
mm, 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 mm. Mm. Yeah. Um, so in terms of computers, I am not sure. Like, of course we can, describe what's going on in CPU, but if we want to, you know, uh, explain the function in CPU, for example, like computer, just display image, right? And then in order to understand what's going on for that purpose in CPU, like we do in the brain neuroscience, like we see the world, then we investigate, okay, first we have this, rotation, not rotation, orientation, detection. And then after that, that is, integrated and then form some outline. And then that with, again, integrated with some color information. And then in the end, we have this kind of phase. And that kind of process, if we, um, yeah, so your point is that, the computers is kind of serial processing, or we can kind of interpret, right? But at the same time, I don't think, we still can't, understand how it works in a sense. Does it make sense?
Yeah, I know what you mean. But yeah, that's just something I remember from learning cognitive psychology. They would start from how the computer in a computer you would manipulate information in a way that you have a series of numbers, and then how you manipulate those numbers, and then you create new things. And they kind of speculate that maybe the brain works in a similar way, and then they start to create these theories, cognitive theories, theories about cognition. Yeah.
Yeah. But what do you think about this unified principle or rules? Do you want to you know find, or what is your feeling? I mean, as I said, I want to find some principles or rule in the brain, and that may not be possible based on their claims, right? It's
I guess one way to deal with it is to be clear about the boundary of explanation if
mm,
you were to find some kind of theories or principle. Like if you find, oh, the brain largely works like this under this situation, then I would say that's a satisfactory, finding, right? But
mm,
just be careful not to argue for something like this will definitely generate to all these different situations. Like this is how we see faces, or this is how working memory works.
mm, 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 mm. I see. Yeah. Mm. Okay. Mm,
In fact, I
yeah.
also remember, how binding problem also arise from, the I don't know exactly the time, but it's definitely before 2000s.
Mm,
Um, they said that the binding problem is the brain process color, shape, orientation at different speed. But
mm,
how do these different contents get integrated together instead of, you have some kind of time lapse in perceiving different aspect of the visual experience. So
mm,
why do we see a white duck? Why is it a
mm,
duck? White duck,
mm,
as it is, instead of like, oh, we see the shape of the duck first and then the white colors
mm,
gradually emerge.
mm,
I think, yeah, I think in the context of this paper, it may also be explained in a way that the brain can just they just behave completely differently for a stimuli that combines those multiple aspects.
Mm.
They don't do serial things anymore.
Mm-mm. Mm-mm. Mm. I see. Yeah. Mm. I guess, the reason why I think that, I want to have unified theory is that just based because of my background, I'm engineering background. I have, engineering background, and then in engineering we have, this equation, and then this equation can explain this. Of course, we need to, modify that equation for different, let's say materials and, blah blah blah. But that made me feel like, we may have something similar.
Well, tell me about it. I also did philosophy when I was in undergrad. Like these people, they would bite bullets for like their own theories. Like bite the bullets is like the everyday kind of phrase. So
Yeah.
what biting the bullet means is I argue that my theory is going to explain certain phenomenon as big as the very existence of the external world. And any, catastrophic consequence that comes from my theory, I'm going to take them. So, it's also like follow a very similar mentality, at least from when I was doing philosophies in undergrad, is that philosophers in, the previous like not recent philosophers, but like philosophers before, they really, really want to use the unified theory to explain things. Right? So
yeah. So I may need to change my mind in a sense. Yeah.
I think, yeah, I think our attitude itself should be also data driven as well.
Mm,
Mm.
mm, yeah. Mm, yeah. Interesting paper, and I agree what they said, but you know, just difficult for me to accept that.
I think it will be easier to accept if these kind of things naturally emerges from your own research.
Mm,
I
mm,
think.
yeah. Mm. Mm, mm, yeah. Naturalistic image. Mm, yeah, but
Yeah, go ahead.
I just wanted to say that, we need to, or at least I need to, accept that, the brain developed to survive in a, environment. So the environment is very, important. And then we need to think about how it's like. And then instead of having, just artificial, weird, you know, experimental setting, we should think about the naturalistic environment, and that's very important.
Yeah. And I feel like that's also very expensive too, because when you want to study naturalistically, you can either do like what experience sampling, or you need VR stuff, which are both pretty
Yeah,
expensive.
yeah. Mm, agree. Mm, expensive. I know. Mm, mm. Yeah, they, said that, but that we have, some tools, or we have developed, measuring tools and things like that. So we should use these as much as possible.
I actually have another thought when I was reading this paper. So in this paper, they emphasize on basically the setup needs to be as naturalistic as possible, and also most importantly, the stimuli should be very naturalistic, right?
Mm-hmm.
I think there's another aspect that should be also more naturalistic, which is report.
Report, yeah.
Yeah. So I thought of this because I was recently testing my kind of similarity rating experiment.
Mm.
And also like you know how the similarity experiments we've been running in our lab are largely we compare two stimuli. So the premise for using this similarity experiment is that we want to understand the relations between two visual experience as kind of represented in our consciousness or in our brain, right? So to study this, we ask people to rate how similar two stimuli are on the scale of 0 to 7. 0 being very similar and then 7 being very dissimilar, right? So what I found is that when I was doing my own similarity rating experiment, I find it to be extremely hard to do. Like it's I just experienced a very strong cognitive load and I don't know why. And I took some time to reflect on it. And I think one reason is that between two visual experiences, there aren't many degrees of similarity, like as many as on the scale. Most of the time, two things are either similar or they are dissimilar. If you force me to impose a scale, then what I'll do is that we start to try to maintain a reasonable decision scale across different pairs of visual experience, right? When I try to rate the pair that I'm present, like when I'm trying to rate a certain pair, I need to justify for my current rating of similarity by like remembering, okay, what was the similarity I rated for the previous pair and what did they look like? And what about the pair before that? And I have to do this all the time, making the decision complexity extremely high. And it has nothing to do with the true relations between the two experiences. Yeah, so you know, the report we are asking for here may not be optimal and most naturalistic in a sense.
So in the case of similarity rating, what do you think you can do to measure similarity for naturalistic image?
I would say to reduce the scale to just very different, similar, very similar. I think that would make the decision much easier. And I don't think we need to worry about, lacking richness in the data because, look, like, I mean, the brain maybe just does not represent this experience with so many different degrees, right? That's why it's difficult.
I see.
But I'm not sure about color, though. I've never done a color similarity experiment, so I cannot speak to that. But I to some degree, it may apply as well because some color, if they're really different, then they're really different. There's what's the difference between the similarity of 6 and the similarity of 7? Very arbitrary.
Yeah. Yeah. That's get your point, but it's just difficult, I feel, to think about that because I have never in my life compared to, experience similar or not.
Yeah.
So asking that itself is not, naturalistic in a sense.
Yeah. Well, yeah, you can even go as far as that, right?
Yeah. So
Like very rarely we do that, like certain food we have never ate before, and then we're like, this is kind of similar to something, but it's not similar to something. But these are like very rare instances. In everyday life, it's like this is, a cup, that's a chopstick, and then we don't think about like what's the difference between a cup and are they're just different.
Yeah. So, but again, I get your point, so we need to think about that as well. Yeah. Anyway, so do you have anything to discuss? No? If not, let's wrap up here and see you next week.
Yeah.
See you.